Alright, hell yeah. We got statics, first chapter. Here's problem number 3. And we're converting units. Okay, so we want 600 pounds per foot cubed to kilonewtons per meter squared. Now this one kind of threw me for a loop. And let's say this is a... well, I don't know. This sheet of paper is about a cubic foot. You know what I mean? And so there's going to be 600 pounds on it. That's like 3 people like trying to put their foot on this one. That's a lot of weight. Okay, so now this problem doesn't say, let's say those 600 people, you know, distributed their weight over a cubic meter, which, you know what I mean, is quite large area. No, it's saying, hey, if you have that same force density over this one sheet of paper, and then like the floor's got to hold up, you know, whatever, those 3 people over that little area. Let's say you had that continuously over a whole meter, you know what I mean? And then how much, like how many pounds per meter would that be? Well, you would have a lot. So then I guess the first question is how many cubic feet are in a meter? You know what I mean? If we say a meter is 3 by 3, well, it sounds like there's 9. You know what I mean? But I would definitely say that 1 meter is 40 inches. You know what I mean? So it's really close to 40. It's closer to 40 than it is 36 inches. You know, 1 meter is not a yard. So and it's more close to 10. There's 10 cubic feet, and there's actually like 10.7. But anyway, so that's kind of going to be our conversion there. Now, pounds to kilonewtons. Well, what's pounds to newtons? If I have 1 pound, I like to think of it a couple ways. 1 newton is a McDonald's hamburger quarter pounder. You know what I mean? 0.25 pounds. 1 pound is going to be like kind of 4 newtons. But I would say, if you can remember this, 1 pound is 4.44, you know, just 4 repeated, whatever. But if you can remember that gets you pretty close. The other thing to know is that Mike Tyson weighs 225 pounds. Hell yeah, that's 1 kilonewton. That's 1,000, that's 1,000 newtons. Okay, so if 225 pounds is 1,000 newtons, how about 600? We could do that pretty fast. There looks like there's 3 kilonewtons. So it looks like you have 3 kilonewtons, but then you have kilonewtons per, you know, 1 cubic foot, but you're going to have a full meter of those. So you're going to have 3 kilonewtons there. You get a kilonewton. You get a kilonewton. You're going to have that 10 times. You know what I mean? 3 kilonewtons on all those. So just real fast, we didn't even do the problem, but we at least guessed, and we're going to say that there's going to be 30 kilonewtons. You know what I mean? And is that a fair guess? I mean, because let's do it a different way. If you have 600 pounds here, you're going to have 6,000 pounds over the whole thing, and divide by 4 is going to be... No, so we were way off for whatever reason. Oh, no, we weren't way off because, yeah, 6,000 divided by 4... well, 6,000 divided by 6 is 1,000, but divided by 4, it's like maybe 1,500. But then you got to move the decimal place. That's going to be 15,000. Oh, no. If this is, I'm sorry. If this is 6,000 pounds, how many newtons is it? You got to multiply by 4. You know what I mean? You got to crank this puppy up to 24,000 newtons. And then go over 3. You're going to be about 24 kilonewtons. And is that pretty close to what we got? Cool. All right, so let's now do it for real. We're going to go 600 pounds per foot squared. And then we're going to say that, and then we're going to do this. F equals MA. And we're going to say that 1 newton, you know, in units is 1 kilogram. 1 meter per second squared. You know what I mean? The units is the equation. So always do this and then do it again and be like, hey, well, we're on Earth, so this part is 9.81 meters per second squared, acceleration of gravity. You're going to have the same 1 kilogram, but guess what? It's going to equal 9.81 newtons. So this gives you the relationship between newtons and kilograms. So 9.81 newtons is 1 kilogram. Booyah, booyah. Because now, this is useful information. Because now we can get from pounds to newtons But and then the other one is just that 1 kilogram is 2.2046 pounds. And you can know this by 1,000 kilograms is a metric ton, which is 2,200 pounds. But you know you're just going to have 2,205 or 2,204.6. You know, you do you, but this is how much that I know. You know, and it might even be 2, you know, blah, blah, blah. But anyway, but this gets me close enough. So I'm going to go pounds to kilograms. I'm going to say 2.2046 pounds is 1 kilogram. And then I'm going to go 1 kilogram using that F equals MA. Hell yeah, 1 kilogram is 9.8 newtons. 9.81 newtons. Perfect. And then I'm going to say 1,000 newtons is 1 kilonewton. Perfect. And then how to get feet. I wish I had more paper, you know what I mean? And maybe we just will, you know what I mean? It just kind of makes it tidy. You know, I don't like going, last time I went down below, it got all funky. And so we're going to go, so what do we need? Well, we need kilonewtons per meter cubed. So I'm going to go, and I'm going to do, kind of my way, is I'm just going to say, hey, I'm just going to say this is 1 foot. So I'm going to say 1 foot is 12 inches. And then I'm going to go 1 inch is 25.4 millimeters. And then I'm going to go 1,000 millimeters is 1 meter. This is how I do it. I always use this 25.4 millimeters. I mean, you could do 2.54 centimeters and know that, and then the next thing is 100 centimeters is 1 meter. You know what I mean? You could do that, but I like using 25.4 millimeters. Okay. So what cancels? Pounds cancel, kilograms cancel, newtons cancel. Hey, we're left with kilograms. Cool. So feet's going to cancel, inches going to cancel, millimeters is going to cancel, and we're left with meters. Now, there is one thing. Hey, I'm making a mistake because this is feet squared. Well, yeah, sometimes it's too much for your mind to wrap around like the feet squared. So just say it's feet and then add the squared back in. So now we have to square this entire thing, square this entire thing, and square this entire thing. And I've done this in the previous video, but hell yeah. So let's just do it once. So we have 1 foot over 12 inches, and it's all squared. Well, and I don't want to get off the page. So this is going to say that we're going to square the top, 1 foot, square the top, and then square the bottom. You know what I mean? But the other thing to know, you're putting parentheses around this because we can even do this. This is the same thing as saying 1 squared, feet squared, 12 squared, inches squared. You know what I mean? This is that, and I think that's the one to do. Because now 1 squared is just 1, but you're left with feet squared. And then 12 squared is 144, and then left with inches squared. You know what I mean? So that's how you do that, and then it'll just be money honey. Okay, so, and now we're left with, oh, yeah, they want square meters. So we did it just fine. Now the other cool way to do these problems, that's why, you know, it's going to take me a full hour for this problem, but that's fine, is to guess using a different method, is be like, hey, you have like a 600 here, let's just say that's 1,000. And then divide by 1. This is close to 1. So you got 1,000, divide by 1, still got 1,000. Multiplied by 10, now we got 10,000. Okay, divide by 1,000. Hey, now we got 10. Okay, and now we're going to divide by 100. Okay, so now we got, I would say 1 over 10. I think that's the best way to do it. And then, hey, now you're going to 25 squared. Well, do you think that's just 1,000? Because this, if you have 100 squared, you're going to get 10,000. If you have 10 squared, you're going to get 100. So it's either between 100 and 10,000. It might be 1,000. So even right here, you can be like, hell, this might be divided by 1,000. So now 1 over 10, and then multiply by 1,000, you're going to have 1 over 10,000. Okay. And now for the money, you're going to take 1,000 squared, which is 10 to the 6, or 1 million. Because you got 3 zeros squared, you're going to have 6 zeros. So you had, and then another way to do this is this is just 1 over 10 to the 4, because you got 4 zeros downstairs, and now you're going to go 10 to the 6. Well, that's going to leave you with 10 to the 2 zeros upstairs. And now, does that make sense? That this problem, on average, is going to shoot you out an answer that's going to be about 100 kilonewtons. You know what I mean? And we guessed, our initial guess was, 30. You know what I mean? So we're at least within the ballpark on our equation, and so let's pump it out. Let's pump it out. So we're going to put into our calculator 600. Whoa. You probably can't see crap. But we got 600 divided by 2.2046 times 9.81 divided by 1,000 divided by 12 squared divided by 25.4 squared times 1,000 squared. All right, booyah. And we get our answer of, so A is 28.738 whatever kilonewtons per meter squared. And since we had 3 significant figures, who knows if these are significant, but when in doubt, you know what I mean, sometimes in physics 3 is what you want, and you're not going to get too many points deducted if you do 3. You'll probably get points deducted if you do less, and you're wrong. But anyway, so it's 28.7 kilonewtons per meter squared. Now this answer is not in the back of the book, so I could make mistakes here. All right, hell yeah. So now we're going to do the next one. And we got 60 miles per hour to meters per second. All right, hell yeah. Now what's 1 mile an hour? You know, you can imagine that, hey, I'm just walking 1 mile an hour. And how many meters am I moving at 1 mile an hour? I don't know. Do you think I'm moving 1 meter? I mean, I mean, if you're talking about factor of, just if guessing, I'm just making up words. But yeah, 1 mile an hour could be 1 meter per second. You know what I mean? That's not a bad guess. That's not a bad guess. So we just throw this, hey, it's 60 meters per second. Now, if you just know, here's one to know, that if you have, let's say my car is going 20 meters per second. How fast is my car going? If you just know to multiply by 2, that gets you pretty close, 40 miles per hour. But if you know how to multiply by 2 plus a 25% tip, that's kind of my little lingo, then you'll get even closer. So we got 20 times 2.25. You know what I mean? 20 times 2, that's going to be 40. What's 25% of 20? Well, what's 10% of 20? That's going to be 2. So you're going to double it, and then add 1, and then half it. So we're going to have 5. So this would be 45 miles per hour. That would be my guess from miles per hour to meter per second. So if you know 2 plus 25% tip, you can just do the reverse. All this is saying, hey, multiply by 2.25. So if we have 60 and then we divide by 2.25, we should get pretty close. So that's going to be 26.66 repeated meters per second. So there you go. 60 miles per hour is 26 meters per second. Now let's do it on the hella accurate. So we're going to go 60 miles, put the hours below, and now we're going to go 1 hour is, I don't know, I just do, you should always, from engineering, you should always know that 1 hour is 3,600 seconds. Just burn that into your brain, you know what I mean, be done with it. But you could do it in 2 steps. You could say 1 hour is 60 minutes, and then 1 minute is 60 seconds. And then 60 times 60, well, guess what that is? That's 36 plus 2 zeros. Booyah. And now you're just on a roll. So now the hours cancel, minutes cancel, and now you got miles per second. We don't want miles per second. We want meters per second. So miles, we know that 1 mile is 5,280 feet. Miles cancel. 1 foot is, now I like to go feet to inches. So we're going to go feet to inches is 12 inches. Feet cancel. And now I'm going to go 1 inch, and I like to use 25.4 millimeters. I always go to millimeters, inches cancel. And then I'm going to go 1,000 millimeters is 1 meter. Perfect. Millimeters cancel. Now I'm left with meters per second. Okay, so now we go 60 divided by 60. That's 0. And we're going to use that just kind of by tens idea. Is that, these are about the same. So we got 1,000 divided by, so this is almost like 100. So we got 100 there. Divided by 100 times 10 is 1,000. So there you go. So now we're just left with 25.4. So we just used kind of a really simple way to guess. So our answer is really close to 25.4 meters per second. And what was our initial guess? 26. So let's figure out exactly. So now we're just know we're going to crank out the 100% the right answer. Can't make a mistake unless I just type this in wrong. So we got 60 divided by 60 divided by 60 times 5,280 times 12 times 25.4 and divide by 1,000. Okay, and we get our answer, 26.8224, whatever, meters per second. And now we're just going to say, hey, is it just two significant figures? I would. So I would just say this is 27 meters per second. But I don't know, you know what I mean? In physics, I don't think anyone's just going to go crazy if you had three significant digits and go 26.8. It's going to be the wrong answer, but hell yeah, it's at least we kind of get it. You threw it into your calculator, you know what I mean? We know, but anyway, if you're driving a car, no one says, hey, I'm going 60.3 miles per hour. No, that'd be insane. So yeah, this point is ridiculous. It's ridiculous. But anyway, yeah, you're going 27 meters per second. That's fair enough. You could see that on a gauge. Okay, hell yeah. So just moving right along. So now we got 10 megagrams. So yeah, hell yeah. So you got 1 gram, you got 1 kilogram. That's 1,000 grams, and then you got 1 megagram, and that's a million grams. You might have a microgram, and I think a microgram is just 1 over 1,000 grams. 1 divided by 1,000 grams, and because then don't you have like what the hell is that called? But that's going to be 1 over 1,000,000 grams. You know what I mean? A microgram. No, oh yeah, this is milligram. Duh. Yeah, this is a microgram. Milligram is 1 over 1,000 grams. 1 over 10 to the 6 is a microgram. Megagram is what we want. Cool, it's 10 to the 6. Alright, can we just bust this one out? And no, we can't, because we're going to convert this to slugs. So we got to go F equals MA. In the SI units, this is saying 1 Newton is equal to 1 kilogram meters per second squared. And you can put a 1 on this. 1 Newton, 1 kilogram, 1 meter per second squared. Cool. So the same thing is 1 pound, U.S. customary, 1 slug, feet per second squared. So if you have 1 pound, 1 slug, 1 foot per second squared. And what's the weight of a slug on Earth? Because your acceleration is going to be 32.2 feet per second squared. So 1 slug is going to equal 32.2 pounds. You know what I mean? So now you have a relationship that says 32.2 pounds is equal to 1 slug. So because we'll need to know, because we'll probably have to convert, first to pounds, which we know, and then to slugs maybe. And then also know that 1 kilogram is 2.2046 pounds. So we know that. And then from this, you can do the same thing. That 9.81 meters per second is the acceleration of gravity. 1 kilogram, and then you get 9.81 newtons. So this also gives us the relationship that says 9.81 newtons is equal to 1 kilogram. Okay, cool. Because now we have megagrams, which is 1 megagram is 10 to the 6 grams. And I could have wrote this. There's no reason that I couldn't have wrote that just all out. You know what I mean? All the zeros. Okay, and now I'm just going to do 1,000 grams is kilogram. You know what I mean? This is my way to simply get to kilograms. So micrograms, grams. So now we got kilograms, and now we're going to go from kilograms to we'll just go straight to pounds. These are our 3 options, and we'll go 2.2046 pounds. And then, and now we need to get to slugs. So we know that 32.2 pounds is 1 slug. And now we're on megagrams to slugs. That's it. And then we did it. So now let's just use our guess. And then what's a way that we could guess this? Because we have, this is kind of a bizarre number. I don't even know. I mean, but it's saying, if you can get there, it's saying it's 10,000 kilograms. You know what I mean? Because you have 10,000 grams, this is, you have 10 million. This is 10 million grams. 10 million grams. Decimal place 3 times, you get 10,000 kilograms. And isn't a pound, well, wouldn't this be 20,000 pounds on average, just real fast? And then it's 20,000 pounds. But then how do you convert to slugs? Well, you got to divide by 32.2. Let's just divide by 20. Hell yeah. So now you'd have 1,000. So our answer is going to be pretty close to 1,000. We're going to divide by 32, so I'm going to guess 678. So anyway, that gets us there. And let's see what we got. So we got, if we do this million divided by 1,000, this is just 1,000 on top. And then multiplied by 10, this just gives us 10,000. And then we're going to double it, so we're going to have that 22,000 divided by 32. So we're right in there. Yep, because 22,000 divided by 32.2. If it was divided by 22. We're maybe 700. Anyway, let's let's do it. So we're gonna go 10 times 10 million divide by 1,000 times 2.2046 divide by 32.2. So this is kind of what we're doing. Let's do it. 10 times 10, 1, 2, 3, 1, 2, 3. Divide by 1,000 times 2.2046 divided by 32.2. Hell yeah. Oh, whoa. Somewhere I was off on my guess. Shoot. Okay, so we have 10 times 10 to the 6. Okay, divide by 1,000. That gives us kilograms. 10,000 kilograms times 2.2046. This gives us 22,000 pounds divided by 32.2. No. I did my calculation right. So that's good. We double checked ourselves twice, and now we're probably going to get the right answer. 684.658, blah, blah. And then we'll see what we want. And this is going to be in slugs. Each of these slugs is 32 pounds, so it kind of gives you an idea of what's going on here. And we're going to say 10 megagrams. There's only 2 significant figures here, so we're going to go is 680 slugs. Booyah, final answer. All right, D. So we have, same thing. You have pounds. This is the pressure of the earth. So here's an inch, and there's a column of air above us, or we're in a swimming pool of air. It's just kind of everywhere. It seeps in everywhere unless you make a container and then purge the air out. You know what I mean? And make a vacuum. But this air, it's just like the submarine that went to the bottom of the ocean. That water is going to get in every little orifice of all the electronics and blah, 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 unless you actually, made it watertight for the people and stuff like that. Anyway, so you have actually 14 pounds of pressure. That's like this much. I'm pushing down 14 pounds of pressure right there. Get some more time on the clock. All right, hell yeah. And you're going to have that on every square inch. So now it says, let's say, and then all you want to do is find the force. You know what I mean? That's 14 pounds underneath the table. But now you're going to say, hey, I want you to do that, but over a full meter. So this isn't saying take your 14 pounds and put it once over a full meter and distribute it. No. This is saying take that 14 pounds and then put another 14 until you got a full meter filled up with these. So even just right off the bat, what's 1 foot? You're going to have 144 of these. Let's say you just have 100 of them. Well, you're going to have 144 times 14. You know what I mean? This sounds like it's going to be 100 times 20. I don't know. Let's say it's 2,000. So you're going to have 2,000 pounds over a foot, but now you're going to have that over a meter, which there's 10 feet in a meter, so add another 0. You're going to have 20,000 pounds. That's crazy. That's 10 tons? 10 tons. Over a square meter. So I think I did it right, but anyway, we'll do it multiple times to figure it out. Okay, so that's 20,000 pounds, and now how many newtons is that? Well, times 4. You know what I mean? Almost. You know, let's just times 4 is 80, but let's just crank it up. You're gonna have 100. You're gonna have 100,000 newtons. And then to get to kilonewtons, move the decimal place 3 times. So you're going to have 100 kilonewtons. So holy Toledo, over the whole. So anyway, so now let's do it for real. I think we were pretty close on our guess. So we have pounds per inch squared. And now, you know, just put your finger over the squared and just say, hey, 1 inch is 12 inches is 1 foot. Cool. And now we're going to go 1 foot. No, what the hell am I even doing? I apologize. No. But it is. It's good to put your finger over the square and just say, hey, get rid of it. But what we want is meters. So we're going to go 1 inch is 25.4 millimeters. And then we're going to go 1,000 millimeters is 1 meter. Perfect. We got to meters. But now we got to square these. You know what I mean? Because we want inches to square to cancel, and then the millimeters squared to cancel, because we want to be left with something that says meter squared. So now if we square 1 is just 1 squared is 1 squared is 1, but this becomes 1,000 squared. That's a million. And this becomes 25 squared. That might be close to 1,000. You know what I mean? So again, yeah. So that's that part. And now we want pounds to convert to kilograms. So we're going to go 2.2046 pounds is going to be 1 kilogram. And then I'm just going to know that 1 kilogram is 9.81 newtons. I think that's a real good one to know. And I've just started using this, but it's just always good to go back to that F equals MA. Anyway, all right, so 1 million divided by 1,000 is 1,000. And let's see, what else? Times 10 is going to be 10,000. Divided by 2 is 5,000. 5,000. Let's say it was just 10,000 times 147. So then, or 15. So then you'd have 150,000. But it's half that, so you're going to have 75,000. Now I feel like I did something wrong. Oh, yeah, because we got to newtons, and then 1,000 newtons is 1 kilonewton. Yeah, so 75,000 divided by that, we're going to have 75. 75 answers. So we got a little bit better. So we went from 175. Now we know if we put in this our calculator, we're definitely going to get the right answer. 14.7 divided by 25.4 squared times 1,000 squared. Divided by 2.2046 times 9.81 divided by 1,000. All right, and we get 101. It's because this wasn't 25.4 squared is 645. You know what I mean? So we divide by 645, so that's why our answer isn't 75, it is 101. It's 101.38885. So and how many significance digits? 3. So we're going to have 101 kilonewtons per meter squared. Final answer. We did them all, but we used that method of being like, hey, can we just guess? And then once we get our equation, can we even guess from there? Turn everything into tens. You know, just round it to the nearest 10. Like this is 10. You know what I mean? And we said that this was 1,000. And you could just say this is 1 and this is 10. You know what I mean? So let's do it that way one more time. So this is 10. This is 1,000. Divide by 1,000. This is a million. 10 to the 6. And then this is 1. And then this is 10. And then this is divided by 1,000. So now you can even do that, say, hey, this is 10 to the 1, this is 10 to the 1, this is 10 to the 3, this is 10 to the 3. So now you have 10 to the 6 on the bottom and 10 to the 8 on top. And now you're just left with 10 to the 2. So 10 to the 2 is our answer. And I did not look up in the physics books what the hell is this called, but it's such a good principle that our answer is on an order of magnitude. Ah, perfect. There it was. I didn't want to look it up. It's an order of magnitude of 10 to the 2. Since we're using the base 10 decimal place system in our math, an order of magnitude of 10 is significant. So we're on the order of magnitude of 10. Now, if our answer was 1, or if it was 10,000, we would be off, by a couple orders of magnitude. So there you go. So that's a quick way to actually just figure out what the order of magnitude is. And you can literally, this is 14.7, but you can literally just change it to 10. If it was 35, change it to 10. If it was 65, well, change it to 100. If it was 55, I don't know. If it's like right in the middle, find something else that's 2. You know what I mean? If this is 55 and then you have a 2 on top, well then, there's a 10. There's a packet of 10. But don't go too crazy trying to, because then you'll just make mistakes. But it is kind of fun finding out the order of magnitude of your answer. It's a real good good way to do any physics problem. And there you go. So I think I'm done. And this was a pretty good one. I'm pretty satisfied. All right, thanks for joining me, and that's a video.